This video is on the objective perform and interpret a hypothesis test for a proportion using technology, right? So the TI-84 calculator that I got, TI-83, TI-84, very similar. And this is number 2, right? So the second video where I'm using a calculator here. So not going to do as much writing as I did as much explaining. I'm just going to go into using the calculator and showing you how to perform a one proportion z-test using the information given. Alright, so again, if you want to see how they're showing you how to do things, just click on more instruction, take a look at their notes, their videos, their examples, and hopefully those help. Now I notice there's a part A here, so it looks like there's multiple parts to this question. So here, a government official wanted to know if more than 90% of the residents in a region had an income that was less than $100,000. So his statement is that the percentage of residents in this region with that kind of an income is greater than 90%. So my claim here is that P is greater than 0.9. So the official randomly sampled 500 residents and found that 461 of them had an income that was less than $100,000. So there's your N and your X, right? Your sample size and number of successes. The official conducts a one proportion hypothesis test at the 5% significance level, right? So alpha is 5%, to test whether the true proportion of residents in the region that have an income is less than $100,000 is greater than 90%. So like I said, the proportion is greater than 90% would be the alternative hypothesis. That's the claim. And then the null hypothesis would be that it's equal to 90%. Right? Technically, you'd write less than or equal to, but we're going to assume the equal part. So this first part is what the setup for this test. The null hypothesis would be P equals 90%. The alternative is the claim here that the proportion is greater than 90%. And if it's that, and if it looks like that, that means it's a right-tailed test, right? They got the left-tailed down here, but that's the other way around, right? So it's definitely a right-tailed test. So click on that. All right, that's part 1. And then, of course, they're going to have more to it where you actually do the test. Now use the calculator and identify the test statistic, the p-value, right? And I'm sure they'll have us make the conclusions afterwards as well. All right, so let me pull the calculator up. Remember how to do these tests. You go hit the stat button, go over to tests, and then the z-test was for one mean, a population mean, mu, when sigma was known. A t-test was for a population mean when sigma was unknown. We're going down to number 5, right? We're doing a population proportion, and remember the test statistic was a z-score. You worked with the standard normal, so it's a one proportion z-test. So I go down to number 5. Now, this first line is P0. That's what is being assumed from the null hypothesis. We're assuming that P is 0.9, so I'm going to put in 0.9, 90% here. All right, then X is what's the number of successes in the sample that was taken. So remember, the official sampled 500 residents, found that 461 of them had this income that was less than $100,000. So the X is 461, and the N is 500, right? The sample size is 500. All right, and then the next line is, what does the alternative hypothesis look like? Do I have a two-tailed test with not equals, a left-tailed test with less than, or a right-tailed test with greater than in the alternative hypothesis? You see its P is greater than 0.9. So that's this third option. All right, and then I go calculate and look at all the stuff that shows up. So they give us our alternative hypothesis up top. On the bottom, you have the sample size and then the sample proportion. 461 divided by 500 would be about 0.922. 92.2% of the sample had an income less than $100,000. But the important stuff are these two lines. You have your z-score. This is the test statistic. This is the z-score for your sample proportion. 1.6. Now they ask us to round to 3 decimal places. So 1.6397, but so that round up to 1.640 for the test statistic. All right, so down here I'm putting 1.640. All right, then the p-value is the line right below that. And that's the most important one, right? Because what we're going to do is compare the p-value to alpha, right, to the significance level, and decide whether or not we're going to reject the null hypothesis. So p here is 0.0505, which to 3 decimal places would round to 0.051. So 0.051 for the p-value. All right, so that's all they're asking me to enter here. All right, so wonderful, great, and they talk about how they entered things in the calculator. And then I'm pretty sure they're going to have me now make a conclusion. Yes. All right. So part C, which of the following are appropriate conclusions for the hypothesis test? So first you make a decision, and it says select all that apply. So one of these two and then one of these two. Do we reject the null hypothesis or not? Remember the alpha here was 5%. All right, they have 5% significance level. The p-value is bigger than that. It's 5.1%. It's barely bigger, but it is still bigger. And remember, when the p-value is bigger, larger than alpha, you do not reject the null hypothesis. So I'm going to click on the part where it says we fail to reject the null hypothesis. And if we're not rejecting it, that means we're keeping it. Right? We're keeping this, meaning that we're not keeping the alternative, which was what they were testing, which is what the official was wanting to know. I guess you could call it the claim. So if we're keeping this, we're not keeping the alternative, right? We're crossing this out, that p is greater than 90%. Another way to say that is that there is not enough evidence to support this statement, that p is greater than 90%. So at the 5% significance level, the data provides sufficient evidence to conclude that the true proportion is greater than 90%? No. We're saying we're not supporting that, right? So at the 5% significance level, the data do not provide enough evidence to conclude that this proportion of income, people with income less than $100,000 is greater than 90%. All right, so again, these two would go hand in hand. All right. Hooray, hooray. And I think that's it because we made our conclusion. All right. We've made our conclusion. And again, please read through your answer explanations. Right, so hopefully watching me go through this again with the calculator, maybe reading that, looking at the more instruction, hopefully all this stuff helps you out, when you're working on these problems on your own. And thanks for watching.